Hello everyone, welcome to Equal To. I hope you have seen the previous video. If you haven't, I'll link it here in the I button there. You can go and watch it first. This is the second video in the first chapter of Science Class 9 and the name of the chapter is Matter in Our Surroundings. So what we have seen in our previous classes, what is matter? So matter is something that occupies space and has mass. Okay. And matter's classification is generally based on physical properties and chemical properties. We also did an activity where, we didn't actually do the activity, we just saw. Okay, the activity was adding some salt into water, right? So the inference that we could get from the activity is that salt get into the spaces in between the particles of matter. So this is all that we saw in the previous video. Now if you haven't watched it, please go and watch it first so you get an better understanding. This is just a revision. So we know that matter is actually made up of particles, right? We know that. That was the team that won, team red, right? Remember. So what exactly is the size of these particles, right? These particles, they were able to get in between the particles of water. The salt particles, they were able to get in between the particles of water. So what exactly is the size of these particles? Now we'll do another activity where we'll come to know what exactly is the size of these particles, right? So in this activity, we are going to take a 100 ml beaker just like the previous activity and fill it with 100 ml of water. Okay, the beaker might be bigger. The water level is just 100 ml. Okay, now we are going to add a few crystals of potassium permanganate. So potassium permanganate is a purple colored crystal. Okay, and the chemical formula for that is KMnO4. So you take a few crystals of potassium permanganate and add it to this 100 ml of water. Now you would have observed that the water would have changed its color to purple. Now what you're going to do is that you are going to take 10 ml of this solution. Okay, we have this potassium permanganate solution. A solution is basically like in this case it's potassium permanganate mixed with water, right? It's not a complicated word. You're going to take 10 ml of the solution and you're going to add it to 90 ml of water, plain water, right? You're going to add it to 90 ml of water. Why 90 ml of water? Because it will add up to 100 ml, right, in total. So if you could see the previous beaker and this beaker, you would notice the difference that the new one, right, you added the solution to the 90 ml water. This beaker would be lighter in color when compared to that. And if you do the same process again and again, so take 10 ml of solution from a current beaker and pour it into 90 ml of fresh water again, 90 ml of plain water, you will again see that the color of the solution is getting pale, right? It's not as dark as the previous beaker, as you could see in this image, right? It's not as dark as the previous one. So you can keep on doing this and you will notice that the color starts fading slowly, but it will be colored nonetheless, right? The color will be there, maybe it's just pale. Okay, so what does it exactly tell you? One single crystal, right, or one single crystal or two crystals that we did drop, it has millions and millions of particles in it, right? That is why these particles, they were able to split, they were able to get in between the particles of water, and that is why the solution is colored, right? So this is the inference that you're going to get from it. There are millions and millions of particles in a single crystal. So what exactly does that tell you? That these particles are absolutely small. And one more thing that you could do is, instead of potassium permanganate, you could use Dettol. You could take 20 ml of Dettol and pour it in water. you can take that solution and again dilute it. If you keep on doing that, the odor will be there, the odor of Dettol would be there, but its strength would be decreased. The first solution, its strength wouldn't be there in the nth solution, right? As you go on diluting it, the strength of the odor will be reduced, but the odor will be there nonetheless. And this also adds up to the thing that there are millions and millions of particles. So the final inference that we are able to get is that the particles of matter are very, very small. They are small beyond our imagination. They are absolutely small. Very, 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 very small. Okay. Because you were able to see, right? A few crystals would be more than sufficient to color 1000 liters of water, right? So many millions of particles there. So the particle size is very small. Now, what are the characteristics of the particles of matter, right? The characteristics of particles of matter. So we did an experiment where we dropped potassium permanganate in water, right? So the particles of one type of matter were able to get into particles of other type of matter, right? The particles of permanganate, potassium permanganate was able to get into the particles of water. This is what we call a diffusion, because this happens on its own. Particles of one type of matter being able to get inside particles of other type of matter and they mix up, right? This is what we call diffusion. Now, this is one observation that you see. Particles of one type is able to get into particles of another type. Now, another activity is we are going to take incense stick, the one we use for puja, right? Incense stick, and you place it somewhere far away from you. Would you be able to smell it? Would you be able to smell the odor? No, right? But if you take a sniff at it, if you bring it close to your nose, you'd be able to smell. You'll be able to smell the odor. Now, if the same incense stick, if it is lit and kept at the far end of the room, you'll still be able to smell it. Why? That is another observation that we are doing here. If the incense stick is lit, you will be able to smell it. One more activity. Okay, I know it's getting quite like we are doing many activities, right? We are not actually doing it. We are just seeing it. Even then, too many activities. Please bear with me. We are going to come to the end, right? We take the same potassium permanganate. We are dropping it in hot water, boiling water, and another one in cold water. Okay, so what do you think will be the observation, right? The potassium permanganate dropped in hot water, it will dissolve quickly. The one in cold water, it will take a very long time. And another activity, please bear with me, this is the last one, where you will be trying to like just imagine, like you have a nail, you have a chalk, you have a rubber band. So you are going to try to break it, right? If you try to break an iron nail, it's quite impossible. If you apply a lot of force, you'll be able to bend it at least. A chalk, it's rather easy, right? If you apply some force on it, it will probably break. And for a rubber band, if you stretch it really hard, it will be like it will give up and it will break. Okay, so these are the observations that we make here. Now that is all the activities. Now we'll move on to the inference that we get. Now the characteristics of particles of matter, that is what we are going to get as inference from these activities, right? The particles of matter have spaces in between them. This is something that we have inferred this from the first ever activity that we did in our previous video, where we were able to see that the salt particles were able to get in between the spaces of water. So particles of matter have spaces in between them. The second property is that particles of matter are continuously moving, because in the case of incense stick, you are able to smell it, right? So it means that the particles are moving, and that is why you are able to smell it. So particles of matter are continuously moving. And the next inference is that as the temperature rises, particles of matter move faster. So when you drop a crystal on hot water, it was able to dissolve it quicker because the temperature is, as the temperature is high, it dissolves very quickly. And one more thing that we have to note is that if any object moves, it means that it possesses some energy. It's quite logical, right? Without energy, nothing can move. And since these particles of matter move, we call this energy kinetic energy. So these particles of matter have kinetic energy. So kinetic is just motion, right? Since they move, it's kinetic energy. And this kinetic energy, it increases as the temperature increases. Okay, this is an other inference that we get. And the last one is that particles of matter have force attracting in between these particles. Attractive force they have in between these particles, right? There is a force acting between these particles and it is an attractive force, and this force, it depends on the it depends on the matter that you are considering. It varies drastically based on the material, right? Iron has a stronger force. Chalk's force, the chalk, right, its force is relatively weaker when compared to iron. So these are the inference that we get. So what we can conclude as characteristics of particles of matter: particles of matter have spaces in between them, particles of matter move continuously, and as the temperature rises, it moves faster, and they possess kinetic energy, and they have a force acting in between them, which is an attractive force that keeps them together, and the strength of the force varies based on the material that you are doing. So these are the characteristics of matter. I hope I didn't bore you with this video. We'll try to keep these videos short, and I hope you don't have any I hope you understood it well. If you have any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video, and again, I hope you watched the previous video as well, because we have covered a lot there, and I'll try to keep these videos as small as possible. Thank you so much for watching. If you have any feedback, please let them know. Please let me know in the comments, and see you in next video. Bye bye for now.